Now we will discuss some special considerations that apply when assessing baseline equivalence in cluster-level assignment studies. This figure shows the steps in the review process for cluster-level assignment studies. All cluster QEDs and any compromised cluster RCTs must satisfy the baseline equivalence standard to be eligible for the research rating meets WWC standards with reservations. Otherwise, the process shown in this figure determines whether cluster RCTs must satisfy the baseline equivalence standard. For example, cluster RCTs with high cluster level attrition must satisfy the baseline equivalence standard. In contrast, cluster RCTs with a low risk of bias due to compositional change, meaning they passed steps 3A, 3B, and 3C, and low cluster level attrition RCTs with demonstrated representativeness, meaning they passed steps 3A and 3D, do not need to satisfy the baseline equivalence standard, assuming random assignment was not compromised. All cluster QEDs and all compromised cluster RCTs must demonstrate that baseline differences are no greater than 0.25 standard deviations in order to satisfy the baseline equivalence standard, along with adjusting for baseline differences in the 0.05 to 0.25 standard deviation range. These are the same guidelines as for individual level assignment studies. Certain cluster RCTs may be allowed to have baseline differences greater than 0.25 standard deviations as long as an acceptable adjustment method is used. This option applies to cluster RCTs that meet 4 criteria. First, the optimistic attrition boundary was used for assessing at least one type of attrition, whether that is cluster level or individual level attrition. Second, attrition was low when using the cautious boundary for individual level of cluster level attrition, if applicable. Third, the analytic sample did not include any high-risk joiners. And fourth, random assignment was not compromised. Again, if all 4 of these conditions are met, then cluster RCTs are allowed to have baseline differences greater than 0.25 standard deviations, as long as an acceptable adjustment method is used. The WWC applies 2 versions of the baseline equivalence standard in cluster-level assignment studies. This includes the individual-level baseline equivalence standard, or Step 4A in the review process, and the cluster-level baseline equivalence standard, or Step 4B. Demonstrating baseline equivalence at the individual or cluster level satisfies the standard. Satisfying the individual level baseline equivalence standard as Step 4A means that the individuals who contributed outcome data are similar at baseline across the intervention and comparison groups. The individuals contributing baseline assessment data and outcome data must be the same for evaluating this standard. If they're not, then reviewers should skip Step 4A and proceed directly to Step 4B. When calculating individual level baseline equivalence in Step 4A, the calculations must use the analytic sample of individuals included in the analysis of the specific outcome under review. For studies that analyze cluster-level outcome means, the baseline equivalence calculations must use the same individuals who contribute data to the outcome measure. The calculations can use either individual level or cluster level data. However, when baseline adjustments are required, the study authors must use individual level data to account for the individual level correlation between the baseline measure and the outcome measure, using baseline data from the same individuals who contributed the outcome data. Study authors who apply an acceptable individual level adjustment need not apply a cluster level adjustment because adjustment for individual factors can also adjust for cluster level differences. Studies that adjust for baseline differences using cluster level data but do not use individual level data do not satisfy the individual-level baseline equivalence standard, but they can satisfy the cluster-level baseline equivalence standard, which we describe next. If a cluster-level assignment study cannot satisfy the individual-level baseline equivalence standard, the study can instead satisfy the cluster-level baseline equivalence standard. Satisfying the cluster-level baseline equivalence standard means that the clusters that contributed outcome data are similar at baseline across the intervention and comparison groups. The individuals contributing baseline assessment data and outcome data could differ for evaluating this standard. So, this step allows studies to demonstrate that the intervention and comparison clusters are similar at baseline even if the individuals used for baseline assessment differ from the individuals used in the analysis. Assessing cluster-level baseline equivalence follows the same general principles that we discussed previously for Step 4A in the review process, but there are 3 unique requirements to consider at Step 4B. First, to demonstrate cluster-level baseline equivalence, cluster-level baseline means must be computed using acceptable baseline samples. The WWC allows 3 types of samples for computing the cluster-level baseline means for cluster-level baseline equivalence. One type of acceptable baseline sample is a sample composed of the individuals in the analytic sample from any pre-intervention period. A second type of acceptable baseline sample is a sample composed of the individuals from the same cohort within the same clusters as the individuals in the analytic sample. The baseline data may be obtained at the time that clusters were assigned to conditions or during the year before clusters were assigned to conditions. And a third type of acceptable baseline sample is a sample composed of the individuals from the immediately preceding cohort within the same grades and clusters as individuals in the analytic sample. If study authors report multiple baseline samples, reviewers should prioritize the baseline samples in the order they are listed here. Let's consider an example. Researchers used a cluster-level RCT to randomly assign students to conditions in the summer of 2014 and then measured the outcomes for grade 12 students at the end of the 2014-2015 academic year. The table on this slide describes which types of baseline samples are acceptable for the purposes of satisfying the cluster-level baseline equivalence standard. Samples 1A and 1B are baseline samples that use the analytic sample of individuals to compute the cluster-level baseline means. These are always acceptable baseline samples, regardless of the pre-intervention period, because the individuals contributing outcome data and baseline data are the same. Samples 2A and 2B are baseline samples of the same cohort and prior grade. Sample 2A has a 1-year gap in data collection between 2014 and 2015, and this is an acceptable reference sample because the data were obtained within 1 year before clusters were assigned to conditions. In contrast, sample 2B is a baseline sample of the same cohort with a multi-year gap. This is not an acceptable baseline sample because of the longer gap between baseline and outcome data collection. This longer gap weakens the degree of overlap with the outcome sample of individuals because of the longer time frame for joining and leaving clusters to occur. Samples 3A and 3B are baseline samples of the same grade and prior cohort that have no overlap with the individuals in the outcome sample, except for any students who repeat grade levels. Although the individuals do not overlap, sample 3A is acceptable because it comes from the immediately preceding cohort. In contrast, sample 3B is not acceptable because the longer gap weakens the degree to which cluster composition may be similar. To satisfy the cluster-level baseline equivalence standard, cluster RCTs and QEDs must demonstrate both outcome representativeness and baseline representativeness. Outcome representativeness means that the individuals contributing outcome data must be representative of the clusters at follow-up data collection, and baseline representativeness means that individuals contributing baseline data are representative of the clusters at baseline data collection. Both of these representativeness calculations should be based on only the non-attriting clusters that contributed at least one outcome to the analytic sample. As was true in Step 3D, at Step 4B, using administrative data can satisfy both representativeness requirements unless review team leadership concludes that patterns of missing administrative data have a high risk of differing across the intervention and comparison groups. Time for your first knowledge check. For which of the following designs would the WWC assess baseline equivalence? A. Individual-level RCTs with low attrition, assessed using the cautious attrition boundary. B. Individual-level RCTs with low attrition, assessed using the optimistic attrition boundary. C. All cluster RCTs. Or D. All compromised RCTs and all QEDs. You may want to pause the video to think about your answer. The correct answer is D. The WWC always assesses baseline equivalence for compromised RCTs and all QEDs. The WWC does not assess baseline equivalence in individual-level RCTs with low attrition. For cluster-level RCTs with low attrition at the individual level, the WWC only will assess individual-level baseline equivalence if cluster attrition is high, or if there is cluster non-representativeness at follow-up. Knowledge check 2. Does the WWC assess equivalence on baseline characteristics for the original randomly assigned sample or for the analytic sample used to estimate impact estimates? Your response options are A. The originally randomly assigned sample, B. The analytic sample, or C. Both the randomly assigned sample and the analytic sample. You may want to pause the video to think about your answer. The correct answer is B. The WWC requires studies to demonstrate baseline equivalence on the analytic sample to show that the two groups in the analysis were similar before the intervention occurred. Knowledge check 3. A study identifies the 20 lowest scoring first-grade students in a school as eligible for a supplemental reading intervention. The study authors randomly assign 10 students to receive the program and 10 not to receive the program. The researchers collect pre-test and post-test data on all 20 students. At pre-test, the students in the intervention group had a mean score of 23, with a standard deviation of 5, and the students in the comparison group had a mean score of 35, with a standard deviation of 5. Will the WWC assess baseline equivalence in this study? Your response options are A. Yes, or B. No. You may want to pause the video to think about your answer. B is the correct answer. This is an individual-level RCT with low or no attrition. We know this because the researchers collected pre-test and post-test data for all 20 students. Because this is an individual-level RCT with no attrition, the study does not need to demonstrate baseline equivalence. Knowledge check 4. Researchers evaluated the impacts of a math intervention with grade 4 students from 5 primary schools. A propensity score matched comparison group was constructed from other students in the district who did not receive the intervention. The authors report analytic sample sizes but do not report information on the initial number of intervention or comparison group students available for matching. The researchers used baseline test scores in the propensity score estimation model, but the only baseline data they report are the means and standard deviations of the propensity scores for the analytic intervention and comparison groups. What additional information, if any, is needed to determine baseline equivalence? Your response options are A. Sample sizes for the intervention and comparison groups at baseline. B. Means and standard deviations of baseline test scores for the intervention and comparison group members in the analytic sample. C. No additional information is needed because the use of propensity score matching creates balance on the baseline test scores. Or D. No additional information is needed because baseline equivalence can be assessed by comparing the mean propensity scores for the intervention and comparison group members in the analytic sample. You may want to pause the video to think about your answer. The correct answer is B. The study uses propensity score matching, a non-random process to form distinct intervention and comparison groups. Therefore, the study uses a quasi-experimental design and must satisfy the baseline equivalence standard in order to meet WWC standards. A study cannot use a propensity score to demonstrate baseline equivalence. Rather, baseline equivalence must be demonstrated on the individual baseline measures that are specified in the handbook. In this example, baseline equivalence would need to be established on the baseline test score measure for the intervention and comparison group members in the analytic sample. The authors already reported the analytic sample sizes, but baseline means and standard deviations still would be needed for the WWC to determine baseline equivalence. Researchers used a QED to examine the effect of an intervention on student attendance, measured as the number of days absent during the school year. Attendance records, as well as disability status and grade level, were collected through school administrative records. At baseline, schools administered a standardized general achievement test to students. The study provided data on the following differences in baseline characteristics for the analytic intervention and comparison groups. The baseline mean difference effect size on the standardized general achievement test was 0.2 standard deviations. It was 0.13 for disability status and 0.06 for grade level. Which of the following would be an acceptable adjustment strategy for handling these baseline differences when estimating intervention impacts on student attendance outcomes? Your response options are A. Simple gain scores. B. Difference in differences adjustment. C. Analysis of covariance. Or D. Fixed effects for units of assignment and intervention periods. You may want to pause the video to think about your answer. The correct answer is C. Analysis of covariance is an acceptable adjustment strategy in this example because the outcome of interest, attendance, is different from the baseline measures, namely the standardized general achievement test, student disability status, and grade level. Simple gain scores, difference in differences adjustments, and fixed effects analysis approaches are only acceptable adjustment strategies when the outcome and baseline measures are the same. Reviewers can review pages 57 through 59 of the handbook, version 5.0, for a reminder of the types of adjustment strategies that are appropriate, depending on whether the outcome measure has a pretest in the same or overlapping outcome domain. A school-level RCT examining the effects of a grade 5 math intervention has low cluster-level attrition but high individual-level attrition. The difference between the analytic intervention and comparison groups on the baseline assessment was 0.35 standard deviations. Cluster-level attrition is reviewed under the cautious boundary for attrition, and individual-level attrition is reviewed under the optimistic boundary. The risk of bias due to joiners is low, and random assignment was determined not to be compromised. True or false? The study cannot satisfy the baseline equivalence standard because the baseline group differences are greater than 0.25 standard deviations. Your response options are A. True, or B. False. You may want to pause the video while you think about your answer. The correct answer is B, false. Remember that uncompromised cluster RCTs can satisfy the baseline equivalence standard via statistical adjustment only under certain scenarios. That option applies to this study because cluster-level attrition was low, or 0, using the cautious boundary. Because the study has low cluster-level attrition, but high individual-level attrition, the study still can satisfy the baseline equivalence standard as long as the authors apply an acceptable adjustment for baseline differences, even if those baseline group differences exceed 0.25 standard deviations. This concludes the 7th module in the WWC Group Design Standards training. Let's review what we covered in this module. We discussed the 4th step in the WWC review process for group design studies, which is assessing baseline equivalence. We defined baseline equivalence and explained why the WWC cares about it. We identified the scenarios in which the WWC assesses baseline equivalence in the review of group design studies. And finally, we described how to apply the baseline equivalence standard to individual-level and cluster-level assignment studies. Remember that you can access all of the resources mentioned in this module on the WWC website, whatworks.ed.gov.